We're going to look at this problem again because the last video we do it but make a bit of mistakes as we go along, so we're going to start it again. What happened is this: you're at A, you want to go straight across the river to B. Now if the river is still, you could have just point the boat straight and go across. Your problem is you have the river flow at 5 km/h downstream, right? Now your boat can go 10 km/h. If you point the boat straight across to B, the water going to push you so that you end up some distance downstream from B. You can carry the boat, get some help and carry the boat up here, point it straight across, and hopefully as the boat sail, as you go across, the river going to push it down towards B. Alright. But the thing is, you're at A. You want to go straight towards B. What you do? Point the boat at a certain angle, so that as the boat sail, the boat will point at that angle and the river going down and you're going straight across to B. You want to find what that angle is. Alright? So what you have now is this. You have, they call it V, the vector representing the movement of the boat. You have this angle, call this angle theta. Now you know that the horizontal component represented by I, the vertical component represented by J. Now I and J are what you call unit vectors. That means they are vectors 1 unit long, and then you can have them point in the direction of another vector. So I would be 1 unit, J would be 1 unit, but I point in the horizontal and J the vertical. Alright? Now cos theta is adjacent over hypotenuse over V. So V, so this here is going to be, since the magnitude of V is 10, this would be 10 cos theta in the direction of I. And this up here, sine theta, is opposite over hypotenuse. So this is 10 sine, the opposite, sine theta J. Alright? So you have the horizontal and the vertical components of the movement of the boat. Right? As for the river, you have a flow of 5 km/h in I direction. So it's 5 cos theta. Well, it's really cos 0 though, It's cos 0. 5 cos 0 I plus, you don't have any movement upwards, so it's 0 J. Alright? Cos 0 is 1, so it's 5I. Now, when you add the vector for the movement of the boat and the vector of the movement for the movement of the river together, call it W equal the vector V for the boat plus, call it R for the river, equal the horizontal movement of the boat is 10 cos theta I, the direction of I, horizontal, plus the horizontal movement of the river 5I, plus the vertical movement of the boat is 10 sine theta, plus the vertical movement of the river is 0. This is J. So when you add the two of them together, you get 10 or you get 5 plus 10 cos theta I plus 10 sine theta j. All right, the j is the movement straight across. This will be the component going straight across 10 sine theta, right? The component of the movement of the boat. This now is a horizontal. This is the vertical component of the movement of the boat going straight across the river. This now is the horizontal component of the movement of the river, of the boat in the direction of the river, I mean. So here now, this must be 0 because what happened? Your aim is to make the boat go straight across. No left, no right movement. It must go straight across. So the vertical, the horizontal component must be 0. So 5 plus 10 cos theta must be 0. Alright? So if you put it together, 10 cos theta equal negative 5 and cos theta equal negative 5 over 10. So theta is cos inverse of negative 5 over 10, which is cos inverse of negative 5 over 10. Is it the same as, alright, let me see, cos inverse of 0.5, 60, cos inverse of 0.5 or 60, you will find that the cos inverse of negative 0.5 close bracket 1 by 120. How that work? It's because I consider the 0.5 to be 60. This here is the 60 degrees. If you use negative 0.5, you get 120 degrees. So the 60 degrees is this angle, then 120 degrees is this angle. All it has said is that if you put the boat in the direction of the river flow and then tilt it, you'll have to go 120 degrees. Or if you put the boat against the direction of the flow of the river and tilt the direction of the boat, it will be 60 degrees. All right? So that is what it is saying here. So this would be 120 from this direction. Or if you use theta equal cos inverse of 0.5, right? Or of 5 over 10, it would be 60, meaning from this direction. In any case, it's the absolute same direction that you would have tilted the boat, right? That is what it is saying. Alright, so that is it for now. Any question, just put it as a comment and I will address your question as needed.